there's a lot of things to summarize when we are comparing E1 and E2 and SN1 and SN2. We want to be able to do a few things in this chapter. So we want to be able to predict the individual products of these reactions if asked to do so. And the second thing we want to be able to do is we want to be able to look at a reaction and make a prediction as to what type of pathway we expect to observe. So there's some things that we have to look at to make that decision. So if we look over here, we can highlight a couple things. So here's a summary of elimination reactions. So promoting factors for E1, weak bases work well for that. Strong bases required for an E2. Solvents for E1, good ionizing solvent. Wide variety of solvents for E2. Right? Substrate, tertiary better than secondary. E2, tertiary better than secondary and primary. So why no primary for E1? Remember, it goes through a carbocation, so those are not stable. Leaving group, well, they both require a good leaving group. The whole chapter requires a good leaving group. And then a couple things about kinetics, so first order versus second order, right, for your E2. Orientation, most substituted alkene here is preferred. Of course, we could get anti-Zeit sets for the E2 also. For E1, there's no special geometry required here for our reaction to occur. But for E2, we need anti-coplanar or transdiaxial. Rearrangements are common in E1, but that's not possible in E2. Other thing to point out is that E1 almost always accompanies SN1, and E2 competes with SN2. So there's situations where we get a mixture, and some cases where we only get one that predominates. Now, as far as our summary of substitution reactions are concerned, promoting factors, well, for the base, we should call it base / nucleophile here. So weak nucleophiles work for an SN1, strong nucleophile required for an SN2. As far as the solvent for SN1, we want something that promotes ionization so that that carbocation can form. For SN2, a wide variety of solvents. Typically, though, we like to see polar aprotic solvents for SN2. Remember, we don't want to solvate the anions, right? Substrate here, tertiary better than secondary. Same idea, you're forming that carbocation. For SN2, methyl, primary, secondary work decently. Nothing for tertiary. A good leaving groups required for both of these situations. And miscellaneous notes, silver nitrate. Remember that forces ionization. And sometimes I think we said we could use heat. Most often you use silver nitrate. The kinetics are listed here, right? First order and second order. The stereochemistry, we get a mixture of inversion and retention with this. And for SN2, complete inversion. Rearrangements, common for SN1, not possible for SN2. So a lot to digest. There's a lot of information there. But I think as we go through this chapter and we learn more, we'll be able to recognize the important factors and assimilate them into some type of an order in which we can make good judgments on predicting reaction pathways.